Hello everyone, this video is about lab 3.1.4.6 from chapter 3 from the course Big Data and Analytics from Cisco, and this is about descriptive statistics in Python. Okay, so the objectives we have here: first we need to analyze the data, and then we are going to visualize the data. So as you already know till now, you need to use pandas or numpy to analyze the data, and to visualize the data you need to use matplotlib. Okay, so here first in part 1, in the analyzing the data, the goal of this part from this lab is to use pandas method to import dataset and generate the following descriptive statistics: sample size, mean, median, standard deviation, and maximum, minimum, and range of values. And so there are already methods built in pandas, so you only need to know how to use them in Python. Okay, so the first task here, we need to import pandas. This is the first one here. So what we need to do, import pandas, and also we need to import matplot as PLT, and we need to generate the figures in the line itself. So, in this page. So that's why we call it matplot in line. I already explained this. Okay, so let's run this one, and here we have the first problem, that invalid syntax with pandas. So import pandas as pt. Okay, and here also we have another one which we have to write here also import as well. Okay, let's do this now. It's okay. Then next step, we need to import the data from the this file, which should be here. Let's check it. Okay, if we type, so I am now in Raspberry Pi, and under the path this one, under chapter 3 data, and if I will type here ls, then I will have the data here that I have to use. Okay, so this one is there, that's needed. Okay, so what we need, actually we need to import this data to a Python. So to do this, as you already also know, now we call the data equals, and then pd from pandas, and then read.csv, and then we include the bug, which is under this directory. There is a folder called data, and under data we have rpi, the name of the file, and it's called descriptive. Or describe.csv. Okay, so let's make sure of the name, the data. This is RPI _ the describe.csv. Okay, let's now import the data, and here we have that the problem. It says that the name of the function should be like this. Okay, in the next step, we need to check the file imported probably by using the head or tail. So okay, so let's do the data that we already import, and then we call head. Let's run this one, and you can see now we have the first 5 rows from this data, and this data has only one column called weight. Okay, by the way, before you work with the data, you have to know what type of data you are working on. Okay, so here is the like a small description about the data. You will use Panda. Okay, you will be working with a file that contains quality control samples for 20 ounce boxes of a food product. The data is used to check the accuracy of the machines that load the boxes. Okay, so this is the data that you are working. What we need to, what type of data we are working on. So the data we have here, we have a data for samples, and then about the boxes of the food product, and then we need to check the accuracy of the machines that load the boxes. Okay, so here we have the data in this format. Next, we need to view the content of the last 5 rows. So let's take this one from here and change the head to L. And here we have the last 5 rows, and here from the last 5 rows we concluded that we have 10,000 rows of this data in the file from 0 till 9,999. Okay, now we use pandas to view the table of descriptive statistics of the file. Alright, so what we need to know to do now, so pandas, we need to know that pandas includes a number of powerful methods for displaying basic statistics on a dataset. The first one here we have the descriptive or describe. So this method is going to display statistics of the data frame itself. So let's use this. And here the data frame we have here called data. Let's run this one, and here we have this like a description about the data. We have a count. This is we already know. We have the mean for all the columns. I mean for the values in the column, and we have STD minimum 25%, 50% of them is like this, 50% of them is with this number, 75% of them with this number, and the maximum value is this one. Okay, so now to work with rounded values of the weight in the dataset, we are going to add a new column for the data to be rounded value. So if we see here the original, you can see that 20.4, 190, 20.55. So we need to round this value. So to do this, we also need to use another method called round, and this one is going to work in this way. So let's do this. Now we are going to add a new column called rounded, and here for data we need to specify the weight. And after that, after specifying the weight, we need to how many digits we need to lose. So not sorry, the one is going to be not here. So here we have the data itself, and then from the data we specify the weight. And from the weight we need to specify another function which is round, and here we need 2 digits after the dot. So again, so we have the new column was going to be called rounded, and then we have the data frame that we are working on, and the column for this one is the weight. It's going to be here, and then we need to round it to 2, and then let's verify that. So from the data we have the head again. Okay, we see here also we have another problem. The problem says that here end of line, like there is something wrong, and as you can see here this one is missing as well. So let's run this one again, and now we have the original column, and then we have the new column we added here, and it's rounded to only 2 digits after the dot or after the period. Alright, so also here it's possible to fill a column with the calculated value as well. So we can also, for example, we say here a column called C, and the content of this column is going to be the difference between column A and B in this case. So just this is for your own information that you can do such thing as well. Alright, now we need to create a new column in the data frame cell. This is called diff, and populate this column. So the content of this column is going to be the amount of weight over under the target value of 20. So we are going to subtract the content of this from minus 20, and in this case everything over 20 is going to be deleted. So in this case we can do something like this. Here we have a new column in the data itself. It's going to call diff as needed, and here we need from the data we have rounded, and here we have -20. And again, we always need to check what we are doing. So here we have head again. Let's run this one, and here we have a new column is there. Okay, now we are going to display some descriptive statistics on this text. And as I mentioned at the beginning of this video, in Pandas there are many methods that are ready to use. You need only to call them and use them. And these methods are listed here. So the first one is called for count, and the second one for the mean, median, STD, minimum, and maximum. Okay, so let's use the count and let's see how can we call it. So we call the data, and then we need for the column called rounded, and then we need only to specify call the method in this way. So here we have the data rounded, we have count. In the same way we can take it from here and do this one here the same. So for round, the second one is going to be the mean. For the third one, it's going to be the median. And for the STD, it's going to be STD. And for the last one, for the range. Okay, so for the range is what is needed here, like the value of the rounded column for the data frame. However, we need to create a, so this is not necessary. So we need to create a variable for each statistics and calculate the range of the values using minimum and maximum. So the difference between the maximum and the minimum is going to be the range of it. So according to this, so we have here the maximum, and then we subtract the data with rounded for minimum. Okay, so let's uncomment then. Here we have again one more time the count, the mean, the median, STD, and the range is going to be like difference between the maximum value and the minimum value. Okay, we run this one here, and now let's print them. You can like simply use print count, print mean, because there are variables here, or like there is no need to like do it in a decorative way, but to look like professional when you are using a Python, then it's recommended to use printing with the format. We already covered this in part 1 in this course. So here for count string, we can actually use the print in this way. So let's assume here there are, and then we put curly brackets, and then records in the data frame, and here we put format, and then we specify the count here. So this value and the output there will be there, and the content of this curly bracket will be the count, which is already there. And this way is a good practice because we don't need to deal with the type of this variable here. In the same way, you can also use a meaning string, and here also we can say that the mean is, and then we put this one, and then we specify here the format, and then we put mean value. For the STD as well, so or for the standard deviation, so the standard deviation is, and then we can specify this one, and then we put format again, and we put STD. Okay, for the range we also will repeat this one. So the range between the maximum value and the minimum is, then we can specify this way, and then we put also again format. And then we put the RNG, and you can also, the maximum value you can specify it also like this, and the minimum value like this, and then in this case you need to specify the like this one, and again the same, but here we need minimum, and then we have this one. So the maximum value is going to be this output of this, the minimum value is going to be the output of this, and the range is going to be the output of this. Okay, let's print here, and now let's print all of them. So now we need to print only the strings, and then we need to put this one, and then again for this one. Okay, here we have the output. There are 10,000 records. The mean is this one. The standard is written not in a correct way. However, there is a spelling error. Deviation is this one, and the range between them, between the maximum value and the minimum value, is this one. Alright, so one more thing here. You will see that this is a very long one. So I mean, after the period, it's very long. So what is now also in Python, there are methods that you can format the string. So here there is a link. I'm not going to go through it now. This is a document for formatting the strings, and this link also provides some examples. Okay, so here, like in the standard deviation, we need to specify that after the float value, after the dot, you just put 2 decimals or 2 digits for the std. So when we run here, then the output is going to be this one instead of this very long one here. Alright, also we covered this in part 1 just to refresh your memory. Alright, next part we need to visualize the data. Okay, to visualize the data here, let's go through this task here. Now we need to create a data frame to contain frequency counts using the value counts method. We already covered this method before, and this method creates a series of objects, not a data frame. So when we apply this, for example, if we have in the column 10 times 1s, then we will have 1 10 times. It's an object, not a data frame. The index column of this series is given by a unique value of the series, and with the column name set automatically to 0. To convert a series of data frame, you can use the toFrame function. Additionally, calling the rest index method on the resulting data frame will transform the very first index column into a new data column. Alright, so here what we need also to know that we also can change the value to frame, and also we can use the index to reset. So what we are going to do in a nutshell, that we are going to create a new column, and this column is going to have a value of the counts on it, or actually a new data frame from the data frame what we have, not a new column, sorry. Okay, so here first we need to create a new variable called the frequency to hold the weights values for their frequencies. Okay, so let's do this. Here we have frequency for data round, and then we specify this method. Okay, so let's now check what is frequent, just like this. And as you can see here, that this time like appears this number, like this one appears this number, and this organize like it's listed in this order. Okay, we covered this method in the previous videos. So, and here is not a data frame. If I going to type or to check the type of this object, it's a series. It's not a data frame yet. Okay. So what next? We need to generate from this series a data frame. So to do this, we can use a method called toFrame. So frequency here is going to be toFrame, and then we need to reset the index. So if we need to check this one, if I type of frequency again, then I will have this is a data frame. Okay, since it's a data frame, so I can check frame.head. And now I have the index, that because I reset the index for, and here I have the rounded value of it. Okay, so what I did now, I actually have the index value here, and then it's the rounded table there. All right. Now use the type function to verify the name of the argument. I already did this. And now we need to change the name of these two columns. From the first one, the index, and then the second one is the rounded. And we need to put them in a format. The first one is going to be value, and the second one is going to be a frequency or frequency instead of index rounded. Okay, so simply we specify the frequency columns to be, the first one is the value, and the second one is the frequency or FREQ. Okay, and then to check, we can just frequency.hit or tail, whatever you want or whatever you like. And here I have the value, and this value appeared this times, this value appeared this times, or this number in the table. Okay, one more thing here, just to refresh the information what we did here. We made first a count for the rounded, which you can see here, and we counted in the frequency. So this for the table rounded, we have this one, and then we changed the series we generated from value counts method into a data frame. Okay, so this is like now we have new data frame. The new data frame is called frequency. The original data frame, the data is totally separated. Now we need to plot the graph and the frequency of distribution that this one we generated. First we specify the figure size 20 by 10, and then we add the labels. You can also add a plot.title, and then however you want, and also you can specify here the a label if you want, but however it's not needed in this task. So here we have the y-axis is going to be frequency, and the x-axis is going to be the weight, and then we plot from frequency or from frequency data frame value from frequency data frame frequency itself, and then we have a circular format, and the marker size is 10, and the color is going to be green. So if we print the output, so the output is here. Okay, so here is needed that experiment with plotting the data with different dimensions, markers, marker size, and colors. You can use this link or this link, but I'm not going to go through them today in this video, but we will cover them in the lab.